Kia ora, folks. Pleasure to be here. It's the first time over the ditch since COVID, so it's nice to finally make it. So day-long mathematical modelling problems as outreach and assessments. So there's a couple of things happening here. The same concept is being used both as an outreach program via nationwide competition, and also I've used it quite successfully as an assessment for first-year maths courses. So that's the connection. Okay. So my context, because you probably don't know who the heck I am, my name's Peter. I'm from the University of Auckland. That's where I teach, and I tend to teach very large courses. So mathematical modelling courses for engineers is my bread and butter, and that's usually 1,000+ students. So all the challenges that come with teaching at scale. And the other thing I do that's relevant to this space is my nationwide competition for senior secondary students. I say mine because I've been running it for 15 years now, and that's upwards of 1,000 participants now. So we get schools from all over the country taking part. I think we had 81 different schools this year taking part. And I do get to teach on the other end of the scale, just very small courses occasionally, which is a nice treat. There I'm talking about 40 students, and that's an outreach course which we run for high school students, but it's a first-year university maths course that they get to do while at high school. So that's a fun group of students. They're all passionate. They're all like people in this room. They care about maths. They're excited to be here, and they're a lot of fun to teach. And the other thing I do, as is sort of shown on the screen there, is I throw objects in the air. I love circus. I have been juggling for a very, very long time. I feel a little naked that I don't have my unicycle here. Those of you who know me know I usually roll around on one wheel, but it wouldn't fit in my carry-on. They don't like. Last time I tried to put it in carry-on, they were very unhappy. So I talk a lot about the mathematics of juggling and the physics of circus. So I go out to schools and talk to them and make things a little bit exciting. So I don't have anything to juggle, so this is going to be boring. But we'll try and engage anyway. So that's just some of my background. I do a whole bunch of other stuff, of course, but that's the stuff that's relevant to today's group. So why the day-long mathematical modelling task? Well, there's a few old challenges, which I'm pretty sure you're familiar with. This is a big one, right? How do we get students interested in STEM, wanting to carry on studying STEM when they hit university? That's a pretty important thing. Certainly in New Zealand, we have a shortage of engineers and other people in the STEM space. The government wants more and more people there. How do we make that happen? This is a big one, right? We've heard some of this come earlier today. How do we get students to see that maths is relevant to them? And in particular, relevant to real-world problems, because a lot of what they see in school doesn't look very relevant. And, you know, someone is designing a pen for their chickens and it's going to be in a parabola. Like, who does that? No one does that. So we've got to try and bridge that gap and make them see that maths is actually useful. And this is a problem I had, is how can I squeeze something meaty and juicy into a very packed curriculum, a very packed assessment structure. In particular, I had a summer school course where we were teaching the entirety of everything in about 5.5 weeks. And I want a nice big juicy project. How can I stick that in when I've only got 5.5 weeks with them? And we've got to have other things, you know, weekly quizzes, assignments, a couple of tests, and an exam. And, you know, where do you put a project in that? It's really hard to squeeze it in. This look familiar? Students think the calculator is God. It's a problem that we've have more and more now. So we've got some new challenges now. So when generative AI can spit out a solution, you know, what's the point of doing this stuff myself? Is what a lot of students say, right? Why do I need to learn how to do this when the computer can do it for me? And of course, the computer can't do everything. And in particular, a generative AI is not very good at questioning assumptions. And I'd argue students aren't very good at that either. And we really need to get them to think about the assumptions behind the underlying mathematical models they're using. And the other thing students aren't very good at, that I'd love them to be better at, is evaluating solutions. And I'd argue these are very human skills. These are skills that computers are not yet that good at. And if they are doing okay at it, it's because a human's driving them and pointing them in the right direction. So these are some new challenges for us that I think the assessment I'm going to talk about will help address, getting people to start questioning their assumptions and evaluating solutions. So what's it look like? This is a photo of a team in action. And I quite like this one because there's a little bit of an inception sort of thing going on here. They did the event several years in a row, and so they started taking photos, and then they went, hey, let's take a photo with stuff on the screen, and let's do that again and again and again. And so they went to town and had a little bit of fun. So what's the solution? Well, the solution I came up with is a day-long problem-solving event. And what does that look like? They get a mystery question revealed on the day. They do not know ahead of time what the problem they're going to address is. And this goes both for the nationwide competition and for using it as a form of assessment. They don't know what's coming until they get there on the morning, wait for the start, and then they see what's coming. It's a team event, so teams of 3 or 4 people. So they're in it together. Together everyone achieves more, and you don't have to be amazing at everything. You can have your little area that you're pretty good at. Maybe some people in your team are good at maths, some are good at writing stuff up, some are good at graphics, and it is a team event. You can throw ideas around, bounce them off each other. It's short and sweet, 8 hours in the case of the competition, and in the case of an assessment, similar time. I went with 8 or sometimes 7 hours, and that works well because students put things off anyway, right? They procrastinate. They're probably only going to do about 8 hours on it anyway if I gave them 3 weeks. So I just make them do it all on the same day. And there are big incentives. In the case of the nationwide competition, we have some sponsorships, so we're able to offer some decent prize money. If you're in the winning team and you win, you're getting $1,000 each, which is kind of nice. And we make sure the teachers who help out on the day supervising get in on the action too, and they get a $500 prize as part of that, just to say thanks to the teachers. So there is some decent prize money up for grabs, and it's free to enter. So that helps promote people being able to take part. And it's also doesn't require any travel because I run the event virtually. Students from all over the country can take part. All they need to do to take part is find a teacher who's happy to supervise them on the day and just act as sort of an invigilator to make sure they behave and don't get Gen AI to do all the work for them. So it's low barrier to entry and a big reward at the end if they do well. And in terms of making students do it for an assessment, I just made it 10% of their grade and then they all want to do it. So you're wondering what kind of problems might I throw at people? This is this year's one. So a little bit of context for you. That there is one of our aging Cook Strait ferries. And no, they're not supposed to be parked up like that, although this is becoming somewhat of a regular problem. So airships to the rescue, maybe. So I'd like you just to chat with the people around you and think, what sort of maths might you want to throw at this if you're thinking first year university level maths? Give you a minute or two just to play with that question. What kind of math skills might come in handy? That's the first question. What's an airship like? And a blimp is a good idea. Yes. Oh, extra context. Cook Strait ferries go from the North Island to the South Island of New Zealand. They've got to get from one to the other. They carry people, they carry trains, they carry vehicles. Okay. Yes, it goes through the Marlborough Sound. Yes, that ferry is definitely crashed and definitely very, very unhappy. No, this is not cool. So now that you've got a bit more context, and remember, I don't give the students any context. Yeah, chat it amongst yourselves. Yeah. Oh, highly relevant.
many decades ago for either the weather or something. And eventually they were in like cargo holds. To get back. So that's real. And I'll take you right. All right.
Cool. I gotta bring you to a close. I just wanted you to experience a little bit of the fear and anguish that comes from what the heck? You know, we don't have any context. We don't know what we're doing. And where do we go from here? And where's the maths in this? Okay. So this question was set as part of the competition, which is aimed at senior secondary. So that's equivalent to your year 11 and year 12 students. But we throw in year 10s if they want to have a go. And so they're thinking of in terms of high school maths approaching this. And I've also used this kind of thing with first year university students whose maths is a little bit further along. So when I'm coming up with this, a lot goes into crafting a good question because it kind of can make or break the assessment. You know, if you have a good question that you get buy-in, that they're excited about, that they can go places with, it works really well. And so the first thing I aim for is something that's concise, just a one-sentence description, something they could tell their parents, this is what we're doing today. If it rolls off the tongue, if you can say it in one sentence, then that's a good start. The second question is, second aspect, I want something relevant. So this was highly relevant. You know, it had been in the news a lot. There'd been multiple articles in the lead up to the competition about the ferries crashing or running aground or running out of steam, and some of the investigations were pretty bad. Why did it crash? Oh, we pressed the wrong button. This is happening not just to one ferry. All the ferries that go between the North and South Island are all pretty much at their end of life. They ordered a new one and then decided, actually, we've spent $500 million and we haven't got anything even started building yet, so we're going to can that. So we don't have a way of reliably getting between North and South Island. It's pretty critical, and this was in the media. So it was definitely relevant. Even students who'd never been on that ferry probably knew something about it if they'd been keeping an eye on the news. I wanted something quantitative. I want a number at the end of the answer so that they feel like, hey, it's a maths question. There's a number at the end of the answer. And of course, the number at the end of the answer is going to depend on assumptions they make and the approach they take. You know, some of the teams were coming up with 1 airship. Some of them were coming up with 50,000. Yeah. The true answer is probably somewhere in the middle, right? And I want something that has some data, but not lots. I want them to have enough to get going, but not enough that they're flooded and overwhelmed with data. So in the context of this question, there is data available about how many passengers per year, how many vehicles per year, how many freight trains per year for some of the ferries, but not all of them. So they had to actually infer some of the absent data for when, you know, one company publishes the statistics, another company doesn't. So yeah, got to do a little bit of work there. And if there's too much data, there is a risk they get overwhelmed. And again, this is really critical. You've got different levels of students, right? Some are amazing, some are not so amazing. And I want it to be a task that's accessible to everyone, no matter where they're at. So something that's got a low floor, high ceiling. Now, a simplistic approach is just kind of figure out how many people currently go across the ferries and then go, right, how many people fit on an airship that I can find, do a little bit of basic division and figure out daily demand and extrapolate off that. But you can really go to town with this kind of problem and do a lot of sophisticated stuff. And some of the top entries, we're doing physics modeling of fluids around stuff and taking into account drag and wondering how's that going to affect their flight time. And some of them designed airships from scratch rather than just looking things up. Some of them were using Google Maps data to figure out over a period of time what the demand, because they couldn't find it, was by different photographs of different days of the week and going, the demand is higher on this day, and lots of cool ways you can go about solving this problem. And that was high school students. And I also, this is really important, particularly in the age of generative AI, I don't want something that has a solution on a platter that's already in existence. And I often get around that by applying a New Zealand context to it. So you could, people forget about us. Yeah. Yeah. So what's it look like on the day when people are tackling a tricky mystery problem that they've only just met, they're not sure where to go about? I love this photo because it kind of shows the different emotions in one photo. You've got someone who's really happy to be there. Someone's like, no, this is just not going well. And someone super engaged and focused. The other cool thing I like about this photo is this is in a little town called Fiordland, which is tiny. Some of you might have been to Fiordland. It's got some nice touristy attractions, but it's absolutely tiny. And there's no way these people would have been traveling up to Auckland to take part in an event, but they're able to do it from Fiordland. This is the other thing that describes, I think, quite nicely the student experience. So that was submitted by students. And I love their unit of measure, which is excitedness measured in smiles per hour. It's a great measure. And this is an absolute roller coaster ride. So I hear from the teachers who are supervising them over the course of the day how it goes. And it really is an up and down roller coaster ride. They have their ups and they think they know what they're doing, and then it just turns to custard. Often at the last minute, there's just this mental panic. And the number of teams who submit with 40 seconds to go on an 8-hour event is quite something. So as you can imagine, there are certain problems with running something like this. Just give you a minute. We're running short on time, but chatting, what do you think could go wrong with running something like this? I'd love to chat with you later if you're thinking about what could go wrong, because chances are if you think it could go wrong, it has gone wrong. So here's an older question. And if you're wondering how is that relevant, some of you might know Cambridge Analytica back when Trump was first coming into office. A little bit of a scandal about how you can persuade people with some money and social media to vote the way you want them to. So this was motivated by that. And this was the reaction to lots of teams that year. They were not happy because that's not a maths problem. And as a mathematical modeler, I went, of course it's a math problem. There's a lot of math we could throw at that problem. But this is a danger. A lot of students get stuck in thinking math problems are the problems we see in the math classroom. Other stuff doesn't look like that. It's not a math problem. And most of the questions I throw at them aren't traditional math problems, but there's a lot of math there. Yeah. Yes, legalized plutonium was the sticker, just in case you were concerned. No. So yet another question. Now, I'm a Christian. I know a lot about David and Goliath and orbiting slingshots. So slingshots historically were not pull it back, release it. They were this thing that you whizzed around and then released. Okay, and that's how orbital slingshot launches work. So that this is in development. People are working towards doing this. They spin things up very, very fast in a vacuum chamber, release it, launch it up, and they're hoping to get into orbit with no fuel, effectively, or very little fuel. How did students go about doing this? Well, you know, remember you could Google this and within 5 seconds find out about the company that's doing this, but this is how they went about it. Because this is their impression of a slingshot. And so that year I had lots of teams talking about their 10,000 kilometer long rubber band that, you know, not 10,000 kilometers, 10,000 meters. You know, don't be ridiculous. Yeah, but the 10,000 meters, which they were going to dig a hole into the ground so that they could stretch it and launch things up. So one of the problems we have is people misinterpreting questions and going in a different direction. Now, they still had fun. They still applied lots of maths, even though the underlying concept was completely wrong. And they still learnt a lot, and still there was a lot of physics thrown erroneously at this problem. But I think it was a valuable experience, even if they went in the wrong direction. Now, this was unfortunately highly relevant. We followed this question with some major natural disasters, some of the worst we'd ever seen in New Zealand. And so the answer to this is lots. So, what was the student reaction to that particular year's question? They really struggled to find the data they wanted. You could approach that question with a statistical approach. It's not the only approach. So a lot of the time they get stressed because they don't have what they need. Oh, welcome to the real world. It's not always put on a platter in front of you. You don't always have what you need to solve the problem. You need to go away and do some research and find it. And a big part of this process is realizing, you know, it's not always served up on the platter. Here's the problem, go solve it. No, you don't have all the data. No, I don't know where it is. No, you have to go and find it. So that's a big part of the event and a big part of what they need to do. Now, the danger is they go and do or only this. They just spend 7 of their 8 hours trying to find some data and do no modeling. So for those of you who don't know, Rocket Lab launched from a place called Mahia Peninsula on the very eastern coast of the North Island. So we've got our own little space industry, which is exciting. They've done a lot of successful launches. And I thought, yeah, be curious. What if we want to establish a lunar colony? Because that's kind of in the news too. What direction do people go in? Sometimes they go in interesting directions. So one team got very focused on the mass of the stuff they had to carry to establish the lunar colony. And they were busy figuring out the mass of toothbrushes. You know, astronauts need to take their toothbrushes. If you're going to live on the moon, you need good dental hygiene. And of course, adding the mass of a toothbrush to the rocket launch mass required to go up for your lunar colony is a little ridiculous. You can get too bogged down in the details, and that's something that happens with students. They get too bogged down in the details. The other thing is they can go off on tangents. Some of you might have seen The Martian. You might be familiar with the importance of potatoes as a food crop for the poor guy who's living on Mars by himself. And so some teams went off into potato land. And instead of answering how many rocket ships we need to get up on the lunar colony, they spent 5 or 6 beautiful pages modeling, the growth of potatoes and how many potatoes you could grow with human excrement, because that's what happens on the Martian. And interesting modeling, though. Do I care that they've gone in the wrong direction? Not really. They had fun. They enjoyed stuff. They did a whole bunch of mathematical modeling. It's a win. Now, what happened with this? Huge variation in answers. Some people came back with answers that were power levels less than that required to run a single laptop. Some people came back with answers of power consumption in excess of the national grid in New Zealand. Again, somewhere in between. And I'm reminded by my brother, who's a math teacher, had a modeling exercise on how big a baby was. And students blindly came back with 3,000 kilograms. Now, for those of you who have given birth, I hope that's nothing like the real number, right? That's a big baby. So we have students who don't question what comes out at the other end. They get their number, they get their units, they're happy, and there's no evaluation. So in closing, here's some tips. If you want to go down this rabbit hole of running a day-long project, I'd encourage you to. It's a lot of fun. You want to create mixed ability groups if you're doing this as a form of assessment. And so I got the class into quartiles in terms of ability based on some tests that I'd already done. I just took one student from each quartile to create the groups so that they weren't all really strong students in one group and not so strong in another. And that was based on mathematics. And of course, that's not the only skill set that's going into this. They're producing a 10-page written report at the end describing their model, all the assumptions they've made, the evaluations of their model, all of that sort of stuff. So it's not a simple, here's my number. It's the process they got to getting their number that I care about. I discovered pretty early on, if you want to do this, you want to make sure they know how to work in groups. Don't assume they do. And so I would run a 2-hour group tutorial on how to work in groups. And I also use that to introduce the assessment, how it was going to be marked, introduce the rubric, got them to do some exercises as a group, figured out their strengths and their weaknesses of each group member, how they might divvy things up, all of that sort of thing went into this so that they could hit the ground running knowing who was in their group, because they hadn't necessarily met them, and how they'd work together. You have to make that with marks or they don't come. And it's critically important they turn up, especially because they need to meet their group members. Detailed rubric is really important. So if you're interested, I can give you the rubric we used. It's a written mathematical report. And by going into detail, you can make sure you get the behavior you want and the things you want across in terms of making sensible assumptions, making evaluations, coming up with a decent model, maybe iterating and improving on it. All the research they might have done, referenced. You need an appropriately sized marking team. If you're doing this in a small course, when I was doing this with a course of 40 to 60 students, I could mark the whole thing myself. 60 students, 15 reports, not too bad. You're going to scale this up to 1,000 plus participants, which is what we've got in our competition. You need a dedicated marking team, and even then it could take quite some time. So don't underestimate the time to mark 10-page reports, right? If you're getting 250 10-page reports, that's a lot of reports. And the last thing is Fermi problems. I'm not sure if you've heard of Fermi. Enrico Fermi, famous physicist, very famous at being able to do back of the envelope sorts of calculations and come up with a pretty good estimate pretty fast to a question like some of the questions we've been posed. And so you could ask something like, how much money could we fit in this room if we limit ourselves to coins. And that's an exercise you could give to a group of students, maybe within that 2-hour group tutorial, get them to work on for 5-10 minutes. They'd have to make a bunch of assumptions. They'd also need to evaluate the sensibility of their conclusion. So Fermi problems are just, Google them. There's a whole bunch out there, and they're great for teaching those skills of making assumptions, working through and evaluating your conclusions. And I am out of time, so I'm going to shut up.